The best way for us to go about this is to see some examples. I'll go through 3 of them. It shouldn't take too long. They are easier, okay, than identities. So hopefully you'll see that. So solve sin x cosine x minus a half cosine x equals 0. Or principal values of x. Okay. And then we're going to express the answer in degrees here. Sometimes you'll be asked to put it in radians, so just be able to go between the two. Any ideas right off the bat? Anybody see what possibly we could do? We're trying to isolate x here. All right, so what could we do to isolate x? You can't cancel them, but you can factor them out. So let me give you an example here. If I gave you 2x squared plus x equals 0, you could take an x out of each one, correct? We're going to do the same thing with the cosines. Okay, so we'll have cosine x, sine x minus 1/2 equals 0. We're reversing the distributive property. What can I do now? Come on, brains. No, it's multiplied. Okay, so if I gave you this one again, what would you do with these, each of these? Does that look familiar? You split it, right? Because one of them has to be 0 to multiply to get 0, so we're going to do the same thing here. We're just using algebra techniques to solve these. Okay, so where's cosine 0? You can use your calculator sometimes on these. Yeah. Or you can look at the tables in the book. Okay, great place to go. And then so if I add a half here, where is sine x equal to 1/2? And we're just where else? Because we need to be between 0 and 90. That's what this means. 30. There you go. Okay, so when we're in principal values, we're just going to be focusing on the first quadrant. Okay. It kind of narrows it out and makes it easier. Is that one okay? Wunderbar. Okay, let's open it up a little bit. Solve cosine squared minus cosine plus 1 equals sine squared. We're going to make it the entire first revolution there, 0 to 2 pi. Okay, we're going to have to use an identity on this one. If we moved it, we would have a subtraction sign. Would that work? No. If we subtract, that's a good thought. If we subtract this over, it's sine minus cosine, but we can't use that because it's not an identity. Is there a way to change sine squared into a cosine? Because we have cosines over here. There's an identity that will allow us to do that. I've put it on the board every day we've been in this chapter. Dum. Anybody? No. We have sine squared. Is there an identity with sine squared in it? Okay. The Pythagorean identity. Is there a way for me to get that equal to sine squared? Yeah. One minus cosine squared, right? So I'm going to put that here. I think I get used to using that because it's going to show up again and again. So, okay, I'm going to subtract 1 from both sides and add cosine squared. So I get 2 cosine squareds plus cosine, and then that's just going to equal 0 because the ones actually cancel each other out. And what can we do?
Where did you get 2 cosine squared?
Cosine squared plus cosine squared. Apple plus apple means 2 apples. Yeah, we're going to do that here in a minute. Yeah. Pretty amazing. And what's next? I just showed you an example of this exactly. Huh? Okay, what do I need to write? Not what I thought you meant. Hello, what do I have in each term? What can I do then? Okay. Take it out of each one. Factor. And then, because I took a cosine out of here. So that cosine divided by cosine is 1. Good question. Okay, so we have 2. Where's cosine x 0? Okay, 90. And, because we have to be between 0 and 360. Yeah, 90 and 270. And where is it? Negative 1/2. You said 120? And there should be one more.
Not 240.
Yeah. Okay, now since this is in terms of pi radians, we need these to be in radians. So we'll convert them all. That one's 2 pi over 3. What's 240 in radians? 3 pi, no, it's 4 pi over 3, that's right. Okay, so there are your values of solving those trig functions. Okay.
Yeah.
So if you see the question has radians in it, you're going to end up in radians. You need to, yeah. The first one, I didn't write it down, but I said we'll just, sometimes it'll say express solutions in degrees. That's when you'd use degrees. You're just giving the man what he wants.
So it says solve whatever for something in radians, it has to be in radians.
Yeah. Pretty much. Okay, last one here. You doing okay? Okay, so we're going to solve 2 secant squared x minus tangent to the 4th x equals -1 for all values of x. Okay. Any ideas?
We use the identity that says secant squared plus 1 equals secant squared.
Yep. Good idea. So secant squared is 1 plus tan squared. Did I write that big enough? Probably not. So I'm going to put tan squared in for secant squared. And we're in terms of tangent now, which is good. Okay. Distribute.
And then I'm going to move all of this over here. So I get 0. So we get that. Are we okay? You with me? Anybody confused? Just along for the ride?
Why did you move it up? Why did you move it on?
Most of the time on these, if you get it equal to 0, you can factor or something, do something algebraically that'll aid you in solving this. All right, so as you can see, all of them we did that. The other two we did it as well. So usually set it equal to 0, and then we can factor this. Okay, this is the same as x to the 4th plus 2x squared minus 3. We need to multiply to get -3 and add to get 2. So what would that be? And +3. These have to be x squareds here because that's x to the 4th. So apply that same thing to this. So it's tan squared x minus 1. Yep. And tan squared x plus 3. What can I do with those two? Huh? No, we just undid that. That was spoiled. This is factor. Split them up. So oh. Oops. I made a typo. Do you care? It doesn't affect us. Well, yeah, it does actually. Here to here. It should be -2. Which all it does is change the signs here. So it's not a big deal. Okay. What? Yeah, this should be +1, and this should be -3. It just changed our factoring a little bit. Is this possible? To have a squared number, -1? Okay, so there's no solutions there. You can't get a negative from a squared. But here, we square root. Where is tangent positive and negative √3? Yeah. Or and Okay, now that's just one revolution, right? We're asked for all values of x, so we have to keep going. The question is, how can we write those into a formula? I think we're gonna need two formulas actually. Okay, how far apart are these? 180? And these are 180 as well, right? So if we do, this is 60 plus 180, okay? K is an integer, so we will get 60, 240, and then it'll cycle back around to the equivalent of 60 and then 240. It'll keep going. And we do the same with. Okay. And we can write this in radians. What is that? 2 pi over 3. Okay. So why would I need to write it in radians when it's not specified? Anybody have a guess? Okay. See how the question says for all real values of x? Which of these two is the real number? Radians are the real number representation of degrees. So if it says for real values, you have to use radians. Okay, and again, we use that because calculus is the math of the real numbers. That's where we're at, okay? Are your minds melted? That's not a good sign. Okay. My intent was to show you that third example tomorrow, but of course your mock exam's in the way, so. Well, I already did. Okay, this is not due until Thursday. Who's going to be in this class tomorrow? 2 of you? Okay. There it is Anna in comp? Anybody know?
No,
She'll be here.
no,
I'm pretty sure that's good evidence. Okay, so there'll be 3 of us hopefully tomorrow.